So, hi everyone. My name is Ash Davies. I'm a senior Android engineer at SumUp here in Berlin, also Android and Kotlin GDE. We're talking about testing in practice today and different techniques and mechanisms you can use in Kotlin using idiomatic features to kind of keep things quite nice and concise. Because I often feel like there's a lot of conflicting advice we get about how to write unit tests. You want to make sure they're explicit, you make sure that they're terse, they're concise, they're isolated, all these different things. And it can be kind of difficult to kind of consolidate all these different things into like a nice use case, which actually makes it enjoyable to write in the first place, because, well, code should be enjoyable. There's also a few quotes I've gathered from people in the community about how they feel about testing. So, starting off with a cat photo. Why test in the first place? Everybody says that you should. You hear all these talks and people on stage saying you should test. Is it even beneficial? Only if you write buggy code. This is from Chet Haas. So in terms of different types of testing, there are many different approaches. Probably the most common one is manual, and this is what you might find with QA engineers, or if you're actually just QAing it yourself. And you're just kind of flipping through the app, trying to find unexpected behavior, either on an application in the wild or an internal distribution, for example. And you might, of course, have heard this quote from a QA engineer at 8:47 in the morning. Thanks to Ronaldo for this. So how to kind of avoid this type of thing? You can obviously have automated tests running in a CI environment, for example. You can have a configuration where you're automatically running these on commit, on new pull requests, or per configuration. And this is giving you robust protection because it's early feedback, fail fast, and it's going to help against regressions. So of the different types of automated testing, you can get this monkey testing, which is, as the name implies, just literally pressing random buttons, trying to get it to do something that it shouldn't. This can actually be automated with AI as well, first time somebody says AI. End-to-end testing, this is where you're testing the entire system altogether, often using actually production APIs. You're testing from the user's perspective to the end of the journey. Acceptance testing, this is if you're testing that the feature meets the criteria, usually given by a product manager, for example. Instrumentation testing, where you're testing using instrumentation of the hardware, physical hardware or device. Most familiar probably is UI or espresso testing. Integration testing, where you're testing multiple components together. Regression testing makes sure that you are not kind of reintroducing an issue that you previously fixed. It's probably quite useful to have. And probably what I'm going to focus most deeply on here, because it's something more important to me, is unit testing. Because, well, frankly, I just like writing unit tests, and maybe I'm just weird like that. There's also quite popular recently is compose screenshot testing. This is quite cool because it has like a low-code automatic generation type of thing, where you're comparing the actual UI against what you're expecting it to be. So you can make sure that your screens say pixel perfect, as it would be, or device independent pixel perfect. But more importantly, testing acts as a safety harness. It gives you that confidence when you're refactoring or changing code that you're not actually going to break something. So if you're refactoring and it's a bit legacy code, for example, you want to have that safety harness in place to make sure you're not going to break anything. But despite this, many people find tests tedious. Perhaps it's not an appropriate use of your time, or you just wanted to do something else, you wanted to work on something more shiny. So with all these arguments, the simple fact is, I don't want to. So the conclusion is, I will not write unit tests. I will be a lazy cat instead. There'll be plenty of these cat photos. But also, perhaps you just didn't have the time. You were under pressure to meet deadlines, and unit tests were not prioritized for whatever reason. Or perhaps you were given this request by a product manager to just skip this one feature. I promise. We'll get back to it. I'll come back to it later. Or, I'll come back to it, and maybe you had the best of intentions, but, life changes, things happen, and maybe you didn't manage to get back to it. So the thing is that automated tests are an investment, and it may or may not save your ass, Ben.
did say that.
You did say that, yes. But if you're not using these tests properly, or if you're not writing them in a good way, they're not going to be that useful to you. You need to actually kind of respect the benefit you actually get from them and what these things mean. If you're aiming for code coverage or something, it's not actually going to be that useful of a metric because, well, it just means that that piece of code executed. It doesn't mean that it executed correctly. And it's important to remember that unit tests shouldn't exist alone. It's not the only test coverage is not the only indicative metric, and unit tests will not give you certainty on their own. They only can test individual features. So, you're going to get situations where the integration is not exactly as you expected. But perhaps my most favorite thing about unit testing, and the reason why I advocate for it so much, is that unit tests not only test your design, but also your logic as well. So it's actually kind of testing that you have good architecture in your code. If you have poor architecture, or if your code is difficult to test, then these things are probably kind of correlating, and there's probably better things you can do. Even if you end up throwing your tests away, you might find yourself with an actual better code base as a result of thinking about testing. So, as mentioned, unit tests can highlight poor architecture and introduce unpredictability. It can be difficult to test. You could have highly coupled components, which are difficult to detangle or kind of break apart. This is especially problematic if you're using a legacy library, for example, and you need to migrate from one thing to another, and you find out that you're chained to this implementation. I've said before that good code is code that is most easily deleted. And that paradigm is true here. You also got things like inheritance. If you're using kind of inheritance over composition, which you should not do, things like base classes and abstract classes that have all this hidden functionality that's kind of that's difficult to find out. Mutability is always a problem as well, where you have a mutable state or a global mutable state where you got different actors changing the properties there, and it kind of introduces unpredictability and unreliable state. And polymorphism as well. This is where code acts in different ways, and it makes it more unpredictable and difficult to kind of predict. So, following all these kind of ideals and idioms and best practices might seem difficult, but that's kind of why we're all here today. Engineering is mostly about problem solving, and it's about balancing problems with solutions and finding the right solution and kind of working on our craft to better ourselves. I mean, I assume everyone here, I hope everyone here is wanting to learn something today and kind of get better at their job. So this is about having fun while doing it as well. So you should also, however, be wary of solutions looking for a problem. I do this sometimes, but of course this is not relevant to Gen AI, which is neither a solution nor a problem. We also see things like advent of code, where these coding exercises and different things which just kind of spark a bit of joy and make us enjoy coding again, because coding should be fun. We should enjoy the practice we do every day, and we should take pleasure from doing so. And these kind of programming exercises help us to become better engineers, thinking of different ways to solve things, different ways to solve problems, taking on new perspectives, and kind of taking that bit of progress at a time, just by taking a different perspective. So enough of theory. Let's take a look at some actual code and how we can take this into practice. Some of this code, it may not compile, and it may look like it was hastily strung together minutes before the conference, but I assure you it was. So, enter thermosiphon test. If you've used thermosiphon before, I'm sorry. So this is sort of quite poor in its way, in its setup, but it's actually reflective of a lot of code bases I've worked on in the past, and the way that it introduces mocks and the way that it builds its setup and everything. You may also notice that there's a lot of annotations here. This is not particular to a particular mock framework, or there are things like mock K annotations and other things like that. That's just ambiguous by design. But I see this every time and wondering myself, why using annotations in Kotlin? It makes no sense. It's a relic from Java history. We have a lot of unnecessary mutability here because you have these late init var classes instances to then use the annotations. So like, well, we don't need to do this. We could have it quite easily with Kotlin. But more importantly, this will not be the last time that I hate on mocks. I've spoken many times about my distaste and why they are terrible and you should never use them. They are overused, abused, and just generally absurd. So one of the main problems is that they verify the interaction and not the outcome. This kind of behavior verification is fine if you're doing certain things, but like most of the time it's actually not correct because you might have the interaction, you might have the behavioral thing going on there, but if it's producing the wrong state, then it doesn't matter. Your mocks are going to be API insensitive, so if you refactor something, the mock will still compile, and then you've got unexpected behavior because you're calling a different function. This can then be prone to runtime changes. It scales really poorly. If you've ever seen code bases with lots of configuration for mocks and setup, it's an absolute mayhem to read through. So you have all these whenever, then these BDD style syntax things, which are just a bit kind of weird. And this sort of setup actually adds exponential noise and vendor APIs to our code that is just really difficult to kind of understand what's going on. So there is a better way, and that is by using Kotlin idiomatic features to provide fakes and stubs. So one of my favorite coding conventions in Kotlin is called a factory function. And this is quite similar to a class constructor, for example, and then you can have it linked to the implementation. So the constructor itself is just a function. Here we have a thermosiphon that takes a heater as an argument. And we can then actually just abstract that away, turning it into a interface. And then that interface will have a top-level constructor function, which does that thing. Now, the nice thing about this is that you can mimic the capitalization there, so it looks exactly as though it would be a constructor. But you're adding that extra seam in between calling the constructor and the actual call site. This means that you can add an additional layer of abstraction, and you can then change the way that this constructor is operating without actually changing the call. Compare that to an actual constructor yourself, and you can only perform initialization behavior on the class that you're actually instantiating. If you've used coroutines, you have probably used one of these classes already. These are things like coroutine scope, completable deferred, channel, mutable state flow, and simple list. These actually are just interfaces with top-level factory functions, and they are a really powerful way of getting different behavior. For example, whilst it may not use the same capitalization, this instantiation of lazy will then make sure it's using the right synchronization method. So you could add additional type checking, additional behavior that would be inappropriate in a constructor. Another really favorite feature of mine is functional interfaces. Originally used with Java interop, this sort of added the single access method behavior to Kotlin. So it's super nice. You just simply add the fun keyword, I like how it's called fun, and then that means you can then quickly and easily create a implementation. Now this means you can easily then swap out mocks for a functional interface. So where we might normally have a mock to set up a pump, and it has this method verification, you simply just have a one-liner. Much simpler and much easier to read. So it's much more concise, and then you can actually have a self-contained behavior inside of a test. This has low cognitive load. You can kind of quickly glance at it and see what's going on, and you can quickly glance at the behaviors and the assertions that are actually happening here. You're not having this escape logic outside of the method, and it's much easier to read. But you're likely to probably have more than one test. Software design evolves and requirements change, and your requirements will then become more complex, and then your test will become more complex. So it might be tempting to think about how you can start to reuse your code. So you might be tempted to extract values to class members, for example. So this is then moving the behavior from outside of an independent test to then on the class member. And it may seem like it makes sense as your kind of requirements get more complex, but it requires more configuration. And then things are getting more complicated, and you're going to add more things into it, and then you've got this kind of heavy constructor thing, which is taking all this configuration. And then customization is required for each test case. And whilst test frameworks will then, destroy and recreate this class each time it's executed for a single test, so it's theoretically fine for safety, it's sort of misleading in its statefulness, and an entire configuration then is prepared for each test. So if you can simply simplify your behavior with a factory function to have that kind of alternative constructor that you can use for test cases, then you avoid these member variables, and you have this, again, isolated behavior inside your test case. Now this moves on to the argument about dry versus damp code. If you're familiar with the dry principle, don't repeat yourself, so remove duplication. You want to try and keep code as reusable as possible, and it isolates the change to the place where it's actually being called. But this often means that you're going to have to cater for multiple scenarios, and then your code becomes a little bit more ambiguous, a little bit kind of more general, and it's a little bit less information that it's communicating. And you compare that to DAMP, because developers really love acronyms. A little bit of duplication is allowed because it assists in readability. You have a bit more of a declarative syntax, which is more relevant for your use case. Think about DSLs in this case. And there's an emphasis on meaningful naming. Of course, you should always use meaningful naming, but the emphasis is here. But these two concepts are not mutually exclusive. It's our job to sort of balance this duplication with descriptiveness and use the best tool for the job. Because in test cases, you're often going to be testing multiple scenarios, different variations upon the same thing. It actually can be much more beneficial to have more readable tests in this case. So you can consider perhaps just using damp in test and dry in production. And that will be more descriptive and helpful to your scenario. Speaking of description, programming is hard. Trademark. Sometimes weird errors occur. Your code might not always act as you intended to, or you might not always get the same behavior because you get some weird things or weird behaviors coming out. And you can spend days or hours or days or weeks debugging this and trying to find the cause of this problem. And then when you do find this, then you might be tempted to write documentation to say, hey, this weird error that happens in this actual weird use case. But the problem with this is that documentation is fragile. It expires much quicker than code does. So it's kind of really difficult to keep this up to date because you might refactor some code out, and then the documentation maybe doesn't make sense anymore, but you don't want to actually delete it because maybe it would be useful for somebody in the future. But actually that's then providing misleading or inappropriate information, and you're actually going to end up with conflicting stories. The best outcome here is that the documentation is ignored, but most of the time, it's actually going to be misleading or introducing kind of weird, causing weird assumptions and end up in actually a worse place than you were in before. So lots of hackiness there. Plus, some documentation can be really quite funny to read. Just don't take it as truth. So we've probably heard before that ideally code should serve as its own documentation, but it sometimes needs more context. Sometimes you need to describe a bit more business logic behind that, or what the decision was made that led you to this scenario. And that's why you can use tests with human readable language to your advantage. So the name of the test there is actually a bit more descriptive about why this behavior is there. And you're actually tying it to the code. So this simple use of naming then builds a bit of a narrative. It tells a story in code, which is less likely to expire as documentation. And furthermore as well, commit messages are a wonderful source of documentation, and if you've ever had to kind of go through Git blaming, Ben gave a talk earlier about this. Commit messages are really useful for this, so always give a useful and easy to read commit message, because the nice thing here is because it's directly tied to a piece of code. You've got that commit hash. It represents a single time in history, which is immutable with the time and attribution. And this sort of source of confusion and misleading documentation is not just for other people. It's not just for new developers, for people who join your team from other teams, for example, or for whatever reason. It's actually going to be you next week. If you've ever come back to your code after a weekend and thought, what was I thinking? Or what is this even doing? I find myself getting this all the time, or maybe it's just me. So what I'm trying to do here is to demonstrate how you can use things like functional interfaces and higher order functions and these type of idiomatic Kotlin features to write code that is both damp and dry. So you have self-contained unit tests with factory functions that help you kind of build these things in nice idiomatic ways with an emphasis on declarative syntax with minimal duplication. But a bit of duplication is fine. But what about context, you might say? If I'm going to fake everything, how do I fake context? And that's often a very valid question, because you get sometimes classes from certain frameworks that are difficult to fake or provide different alternatives for. And encapsulation is a really good mechanism here, because you can encapsulate your usage of a mock inside this function that provides only the implementation that you actually require. So all this ugly kind of when framework-dependent mocking code is hidden inside of this function, and then you're just calling it as though you would a normal functional interface. This brings us on to interface segregation. So the idea that you shouldn't have to implement all these extra classes if you only require the mechanism from one function, for example. It's much better to mock much better not to mock if you can here. So if you've got an interface that you own, for example, then you can quite easily kind of extract and break it down into smaller interfaces. So if you own the class, it's much easier, but you can still do it if you are a bit creative. So this example shows a concrete class. We've got the menu provider that builds upon the navigation state. Quite simple behavior here. Your case might be a bit more complex, but you might notice that the menu provider only uses one property of this now state store, and you've got this kind of complex concrete implementation that we then kind of have to either mock out or perform every function underneath the test. Well, if we only have this one implementation, then maybe we can extract this out. And with only a few lines, you've got this new interface, and the responsibility is reduced, the scope is narrowed, and fakes become much more easier. And this implementation can be backed by an in-memory map, for example. Or it could be backed by preferences, for example. Or you could even use machine learning AI for reasons that it makes no sense to me. So it can be, preference nav state store, sentient nav state store, but one thing it is not, and it is not an impl. Please, for the love of God, stop using impl. This is a relic of Java past, and if you cannot think of a good name for your class, then perhaps just name it the class itself. So you might be tempted to use impl because I've got a test implementation as well, or I need to do this because we're using Dagger and I have to use a binding on the interface there. Give it something more descriptive of the behavior that it's actually doing, the implementation that it's actually using. For example, we had the preferences store earlier. This gives the reader a little bit more information about why it's there. You can also use a factory function as well to provide an anonymous implementation instead of using impl. So there are lots of options here you can actually use to avoid this naming structure, because the only thing this tells me is that the author didn't know what to name it. And what if your dependency is a Kotlin object, for example? Kotlin objects are by design singleton instances, and it might seem a little bit bit difficult to refactor because it's actually referencing a static reference, so you can't quite easily mock it as well. Well, that's actually quite easy to change out because you can just provide this companion object of an interface. So you define the requirements on the interface and add a companion object as a default. This is nice in some states, but it can lead to a bit of language abuse. I've often seen people using the operator function of a companion object to then instantiate this as an alternative constructor, and then even worse, actually making this suspended, which is fun. Yeah, this is kind of language abuse, and you should really kind of think twice before employing it, because maybe it might be simpler just to go with a top-level factory function. Simpler, easy to read, less indentation, and less noise to your code there. So It might also be tempting to test class properties. So you've got this assertion here that's actually just asserting that this property is a certain value, or is enough to do that. But this is going to be brittle because you're not actually testing the state as a whole. For example, if we then refactor this state to add an extra property, this text no longer verifies that we have good water for good tea. Which is really quite important. It's much better to then build your expectation as an actual object to compare it against. This is to make sure that your test is sensitive to API changes, because you do actually want your API to break tests if you change it. If you break your API, you're breaking your contract, and you should know about it, because otherwise this goes unheard of, and then only when you've got consumers, which may be people inside your own team or your own app, will then notice that this API has changed, and it's going to be difficult to work with. But also quite importantly as well is that this is going to give you a really helpful error message if it fails. This information is kind of, this is my expectation, and this is what actually was going on. It's testing the entire state, and it's much easier to work with. So, wrapping all this up into a nice little conclusion, in general, you should prefer functional interfaces wherever possible. This means that if you're using the single access method interfaces from Kotlin, that you're going to have a limited scope of responsibility. Your class is not going to be doing too much if you're familiar with the single responsibility principle. Utilize factory functions to isolate the behavior in tests is really useful. And you want to segregate the behavior of large interfaces into those of smaller interfaces. Interface segregation principle, as you probably heard. Conclusion of testing: avoid mocks, please. Stop using mocks. They are not necessary. You can quite easily get the behavior with fakes and nice coding, and it employs and encourages you to write better code. Restrict test behavior to inside a single function body. Avoid the usage of class members and other properties that you might not need. It's much more descriptive if you repeat yourself a little bit inside of a class body, a function body. And you want to keep your individual tests idempotent. I find it really hard to pronounce idempotent. This is where it's pure. It's going to behave the same way every time with the same input. You're not going to end up changing the state or changing the environment around it. And finally, it's okay to repeat yourself a little bit in tests. It's much better to be a bit more descriptive, a bit more declarative, and give that important information that you're using as documentation in a test scenario. Because whilst you should still be holding yourself to a higher standard in test code, as I mentioned before, test code is just production code that doesn't ship, it's okay to be a bit more descriptive. So that's actually all of my content, but there's usually a bit of extra content when you're preparing a talk, things that didn't quite make it in. So I thought I'd just add these little outtakes just because, well, shits and giggles. There's a commit message from Ramangi, who wrote this long story about the flaky flake test. And it's a lovely little story there, and I recommend you go checking it out. This is on the Google source code there. I'll share the slides as well later so you can see. I wanted to highlight as well how sometimes when you're writing TDD, it can be a little bit weird, and you end up this kind of writing code just to get your test to pass, and it actually doesn't solve the actual problem. So here we've got a few if statements. I think there was a comparison as well with this is even and is odd. So like just keep on adding else cases. And finally, unreachable states. I mentioned before with documentation where we're having this kind of really long thing where it's like, okay, I'm writing all this information that I want to convey to future readers, but actually I'm not super confident in the code that I wrote myself, so keep it into the code. And yeah, that's everything. Thank you.